28. And finally, C8 is C7 plus 8. C7, which is 28 plus 8. So 28 plus 8 is 36, right?
Yes, sir.
All right. So we've filled up that table with the triangular numbers. It now says the nth triangular number can be found directly using this formula. Okay, so they even gave us a formula eventually. It now says is 1275 a triangular number? Give a reason for your answer. Okay, so let me ask you, how do you think we'll solve this particular question? How do you think we'll solve this particular question? Is 1275 a triangular number? Can we solve it by just looking at the number? Now, from the pattern that I've seen here, some of them are even numbers, some of them are odd numbers. So we can't even say that, you know, all of them are even numbers. So there's no likelihood of having an odd number. So um, because we can't say that, then I mean, just by looking at it, there has to be another way we'll go about it. So, do you have any idea?
Mm, should we? Okay.
Yeah, go ahead.
I
Uh,
was thinking we are
this
going
is
to use the T formula.
okay. The formula that they gave us, right?
Yes.
Okay. So if we are using that formula, now we don't know what position. If this number is a triangular number, what position it will be? Because it's like we are the ones doing the investigation. They asked us, is it a triangular number? Somebody could have claimed, oh, 1275 is a triangular number. By giving us that job to be like detectives to find out if the person telling the truth or not. So that's the angle we're coming at this question. The only way we can verify that is to find out if there is a certain n that this formula will be true for. So let me put down the formula first so that we know what our formula even is. Tn equals n into what? And now you see this thing I just said, as basic as it sounds, is the same principle for any sequence. So they can just tell you one number, they'll just tell you one number, 56. Is 56 a number in this particular series, or is 50 is 116 a number in this particular arithmetic series? Your job now is to say, okay, we'll find out. So you go and look for the nth term of that series, equate it to the number, and find out if there's a particular n that will give you that number. So in this case now, what I've just written down is the formula that I want to find out if there's any number that will give us 1275. So is there anything, any n for which 1275 will show up for it? So let's keep our fingers crossed. Remember, um, we don't know the n. So our job is to find the n. If we can find a certain n and a whole number, you understand? It's realistic. It's a whole number, and that means it's not possible. So that's basically what we want to do now. So um, let me put a question mark here, saying um 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 where to find n. So let's find n. Okay. Uh, so now take note again. The question did not ask us to find n, but if we can find a certain n that is a whole number and that makes sense, because uh, uh, that will give us this 1,275, then that means it is possible. But if we cannot find it, then that means 1,275 is not. So maybe I should just put it in the box so that we know straight ahead what we're dealing with. So if we can find a certain n for which, well, let me quickly just my trusty keyboard, uh, for which uh, is 1,275. Then don't worry, that's it. I wanted to put something there. I have to see with 1,275. Then the number is that is is we cannot find a realistic number and in bracket. What I mean by realistic, it has to be a whole number or what we call an integer, a whole number, an integer. Then 1,275 is not in that is okay. So let me I just thought I should put that here. So whenever you're doing your extension, it will, you will see. Okay. So what did I want to put in that space? This is what I wanted to put in that space. Because that guy will not be able to, I didn't put so much space there. But let me just see how I can fit it in. For which EN is 1,275. Okay, so you understand what I'm doing, right?
Yes, sir.
Goodness, are you there? Okay, good.
Yes, sir.
Okay. I think there's a bit of a delay. So it's like you're not hearing me immediately I'm done talking. But don't mind the internet. We'll still work around that um delay. Okay, so let's go. What do you think we'll do? So, goodness, you're going to help me now. What's the first thing I should do? I have a formula like this. What should I do next? We're trying to find n. In other words, we're trying to make n the subject of the formula. What's the first thing I should do with this kind of thing?
And
Yep.
bracket n plus 1, and then I think you have to multiply the bracket.
What should
So
I
n squared
do?
of over
Okay, I should multiply the bracket. Okay. Yeah. Yeah. Okay, I could do that. N square now, right? Plus N, isn't it?
n squared plus n over 2.
Right?
Yes.
Okay, so what do I do next?
I think
What do I do next? What do you think I should do? I should take care of this too, isn't it?
yes, remove the 2.
The only way I can take care of that too is to do what to both sides. Yep. What do you think I should do to
Okay.
both sides to take care of that too?
Mm, to multiply by 2.
Exactly. Correct. Multiply both sides. And let me just do BN. You know what BN means, at least in our distance. Both sides by 2. Okay. So, um, let's go to do that. If I multiply both sides by 2, that's going to leave me with 1,275 times 2. Let me just write it so that we know what we did on that step. And then if you multiply this other side by 2, that 2 will leave, leaving me with n squared plus n. Okay. So in case somebody who is wondering and looking at our steps and saying, how did the 2 disappear? Let's give the person the privilege of seeing everything. Okay. So 1,275 times 2 will give me what?
2,550.
Yeah, that's right. 2,550. Because 2 times 12 is 24 plus 1, 25. And that leaves us with all this equals n squared plus n. Okay. So what do we do next? It's already looking like there's a quadratic equation somewhere, isn't it?
Yeah, we bring it over and then equals to 0.
Exactly, exactly. So we're going to, okay, so for those who want to see our steps, Abby, let's, like we said, let's show them everything. So we're going to say subtract uh 2,550 from again both sides. Okay, so we go it's now leaving n squared plus n, not my plus is too much, plus n minus 2,550. Okay, so are you already thinking about how we can factorize this guy? Are you already thinking about that? What two numbers
Mm,
um, multiply by themselves to give you 2,550? Uh, yeah, if we multiply them, they'll give us 2,550. If we add them, they'll give us 1. So, well, we can think about it, but then that's a big number. But so what I think we can another thing we can do is we can just use our almighty formula. So that will just save us all the wahala. So if we use almighty formula says I'm replacing n now with x, and it's equal to this is my a. My a is whatever is in front of n squared. My b is the coefficient of n, and sorry, let me put it there. My c is this guy. Okay, so let's put it in. Remember, let me see if I can even code that in. minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so I know you may not need to code this. Me, I just enjoy doing it because nobody will let you go into the exam hall with anything that has anything written in it, not even talk of a formula. So, but then, yeah. Okay, so if I apply this formula now, my b is 1, that's plus 1. So that's just going to give me minus 1 plus or minus square root of b squared is 1 squared. I just put it there. Minus, so I hope you have a calculator already, because I'm going to be multiplying. Anyway, may not be really big, but let's just multiply. 4 times 1 times c. Now, c, you have to take c with its sign, which is minus 2,550. So
So
that
times
bit you will help me with. Okay. So everything over 2 times 1, which is 2. We all know that that is 2, but let's just put it there because we are doing that. Okay, so let's deal with what is under the square root sign. That's the biggest piece. You've already seen that minus times minus is plus, isn't it? So just multiply 4 by 2,550 and then and then add it to 1 because that minus will turn it to 1. What will you have?
okay, I'm trying to put the calculator.
Okay.
Minus 4 brackets
Times 4.
minus
4 times
200.
2,550. Your answer.
I got
No,
100 for the
don't
top
do the
one.
minus. Forget about the minus. We've already done the minus. Minus times minus.
Oh,
You got what?
I added everything together. That's why I'm getting 100, but
What did it say you got?
100, but I
No.
didn't add the right thing. So
No. So, okay. So let me show you what you will do. This thing, we're multiplying 4 times A times C. So you're multiplying 4 by 1, well, which is as good as 4 times 2 and 4. I am multiplying by 2,550. The answer to this,
that's
we're going to now add 1 to it. And I said that the reason, yes, yes. What did you get?
oh, I got 10,200.
Better. That sounds more like it. 10,200, right?
Yes, sir.
So if I now add 1 to it, what would that be? 10,201.
101.
Yeah. So can you help me find the square root of that? It's already looking like it will give me a decimal number. So yes. Anyway, sir, let's not give up. Let's see if there's anything that will come out. So that will be what? Square
Square
root
root
of
of
10,201. A whole number.
101.
Oh, it's 101.
Yes, 101.
Okay. So there goes. I don't know. It looks like it's going to turn out to be true. So minus 1 plus or minus 101. Now looking good. Over 2. So the first value of n. So that means, let's do our therefore, n will be equal to, so minus 1 plus 101 divided by 2, or, which is where the or will always come for quadratic equation, minus 1. Of course, we already know that this second or is not a possible n. You know why, right? Because it will give us a negative number. and we're not
Yeah.
looking for negative numbers at this point. Well, it's only positive number we're looking for. It's kind of biased, and the reason I mean, it's clear because it's a series. Series don't entertain negative numbers at position. You understand? It's nothing. There's nothing like minus. You understand what I'm trying to say, right? There's nothing like minus second position or minus fourth position. It can only be first position, second position, and third
Okay.
position, fourth, fifth, and so on. Yeah. So this one, I'm just doing it for formality. I know that we're not going to use it, the one on the right hand side. So let's work on this left hand side. Minus 1 plus 101 clearly going to give us 100, right?
Yes, sir.
So 100 over 2 is 50. So that
Wait,
means
minus
this
one
this
minus.
number is,
Okay,
yes, plus,
that's
plus,
50.
not minus. This one. So, uh, yes. So 100 over 2 equals 50. So that means that because we could find this 50, that means, yes, uh, so we'll take this one out. Why? Because it's what? It's negative. Okay, so you can just put that as a reason. There's no need to push it. Let's just save time. So what's our conclusion? We're going to say, yes, yes, 1,002, what is the number? 1,275 is uh number in the triangular series. The triangle I want to write it. No, it's there. I want to write first. The triangular series. And the reason is, this one, the triangular series because we could find uh, n and then the bracket 50, 50. Yeah, then, okay, so I believe that's enough for you to give the maybe when you're looking at the calculation again, you would understand what we did back then. For picture. Okay. So do you have any questions?
Yeah, I just want to write them down. But like I want to the top ones.
Hello, good night.
Hello, sir.
So should I scroll?
Hello.
Should I scroll up?
Yes, sir. Thank you, sir.
Yeah, I can hear you. Goodness, I can hear you. Okay.
Oh, I said you should scroll up, please.
Okay. Okay. All right. No problem.
Can you please scroll down a bit?
Okay.
Scroll down. like till the second, sorry.
I should scroll down again.
Yes.
Okay. Like this.
Yeah, it's enough like this.
Okay.
Yeah, can you please go down there?
Okay. So now, I don't even know if I should just give you the this thing for this one. Um, since we let me just let's just I'm just thinking. I don't know if they want you to show that to show your working to conclusion for that one, but let's if we minus one minus 101 is minus 102. So we divide minus 102 by 2. We will have minus 51. Okay. And uh, just like we gave a reason for why we um, can just say we're ignoring it because it's a negative number.
Yeah, I'm done
We
writing.
can say, okay, you are done writing it.
Yes, sir.
Alright. Okay, so let's move on to the next one. Let me make me scroll up again. Okay, take this out of the way. Alright, let me go back to my phone. The next one says something which we've already done actually. If you look at it, it says the n plus 1 triangular number can be written as Cn plus 1 equals Cn plus n plus 1, which is what I was doing here. See, I started doing it from here. So if I knew, I would have been doing it earlier. See, I started doing it from C5, where I was saying C5 equals C4 plus 5. Okay, so that's just it. They're just confirming that where n is an element of natural numbers. Same thing we concluded from the beginning. Natural numbers being numbers that start from 1, 2, 3, upwards to infinity. Okay, next it says write the expression. They want us to write. They don't want us to do these things like show them that we know what to do. Okay, so let me. safely demarcate that. So this is 7b, B1. Okay, so we said we should write that as a single fraction in its simplest form. Mhm. Anybody that doesn't know their way around algebra, algebraic simplification will be lost. Lost that the uh, what word do they even use to compare somebody that can really be lost, like lost. Okay, so of course the secret to every algebraic simplification is to what? Remember that any letter there is a number. Once you remember that, you are, there's no big deal. So you're just asking us to make this thing a single fraction in its simplest form. Okay. So of course I'm sure you agree with me that you can um what are the different things you can do? Uh, uh okay. So since we're simplifying, right, we can do we can do we can do the LCM method. This is what I'm thinking about when I'm saying LCM method. N into n plus 1 over 2 plus n plus 1 over 1. So this thing that I just wrote down now, do you understand it? Do you agree with it?
N plus 1. Okay.
Uh-huh. All right. So what will we do next? LCM of 2 and 1 is obviously 2. 2 into itself is 1. 1 times what you have up there is n into n plus 1. Don't worry, we'll still come to all these removing brackets. But I just want to, oh yeah, I'll play this Mr. Internet connection. Okay, plus 1 into 2 is 2. So 2 will multiply the whole of, don't forget, bracket n plus 1. Now, well, if you really want to simplify it, you may not need to, like open the bracket. If you look well, I don't know which one will be simpler for you, but there are two ways I can do this thing. I can see that there's a certain n plus 1 that is here and another n plus 1 that is here. I can factorize that. Do you get? I can factorize that. If I factorize that, what it means is that I will have n plus 1. Okay. When I factorize that, what will be left in the bracket? When I factorize n plus 1 from here, I'll be left with n. Okay. If you don't understand this method, I'll do the other method. Well, I don't know if you'll understand that one
Mm,
better. But
mm.
let's see. If you cannot understand this one, just let me know. Okay. So take a look at it. Well, all I just did was to factorize the n plus 1 and the n plus 1. Then what is left is the numbers in front that are multiplying it.
Where,
Okay.
how do you get the n plus 2?
So can you see this plus in front of the 2?
O-
Hmm?
Okay.
Can you see
Okay,
the
the
plus in
2.
front of the 2? That plus is preserved when I factorize it. Yes, you get it now.
Okay.
Okay. So if you don't, anyway, don't worry. I like exploring different methods. We'll do the second method, whichever one you understand better. If you understand both of them, it's good. It's good exercise for your mind anyway. So n plus 1 into n plus 2 over 2. This is as simple as it can get. Okay, so you do like this, you're fine. Now the other method, let me take it up from here. Let me draw a line at this point. So the other method says that I'm not starting from the beginning. I'll just take it from this time. Multiply. So that will be n squared um, uh, plus n. What else? Plus 2n. Okay, well, somebody can say argue that they can open the bracket plus 2n plus 2. So um, all this is over 2. And that will now be n squared plus 3n. It's still the same thing, no? It's just that this other one, it looks factorized. While this other one, we don't have any bracket. So yeah, that's just the difference over 2. Okay, so I don't know, whichever one, you know, I think this one looks, I don't know, somebody might argue that if they don't want any brackets, this one looks simple. But if you want brackets, the one on the left hand side looks simple too, the bracket. So which one do you understand better?
The right one.
Left or right?
Right.
The one on the right. Okay. So if you're good with, you can adopt it. You can adopt it if you're good with that. You really push this question up. I'm looking at the next one now. Are you done taking a screenshot of this?
Oh, yes, sir.
Okay. So should I go on to the next one now?
Yes, you can.
Okay. All right. The next one is say what? Prove that the sum of any two consecutive triangular numbers will always be a square number. That is a number in the form k squared. Hmm. Prove. Wow, this one is asking us to prove. Now, whenever you see that word consecutive, what does it tell you? What does the word consecutive tell you?
It's on its own.
I didn't hear you.
Is it like the
It's what?
same thing or is like continuous continuing? Hello?
Okay. Continuing. Okay, I think we have an idea. Yes, 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 I can hear you. So consecutive, right, means um coming one after each other, I think. So yeah, means that one comes directly after the other in a sequence. Okay. Let me just say in sequential order. So, for instance, 2, 4, 6, 8, 10, blah, 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 blah. 2 and 4 are consecutive even numbers, That's just an example. Consecutive odd numbers will be 1 and 3 or 5 and 7. But 5 and 9 are not consecutive at all because they don't come, one does not come directly after the other in sequential order. Okay, so now that we're armed with that, it means that the consecutive in this case is, for instance, Cn being followed by what? Cn plus 1. Okay, so once we have
Okay.
this at the back of our mind, it makes things simple for us, and you can now see that the people that gave us this question are kind of setting us up. They first asked us to find Cn, or they gave us Cn. Then they now said we should find a simple fraction that will give us Cn plus 1. And then we're now going further to, what do you call it? The next question, which is going to ask us to um, sum Cn and Cn plus 1. Because that's what it's saying. Prove that the sum of any two consecutive triangular numbers will always be a square number. That is a number in the form k squared. So let's look at it. It's a proof. So, and usually with all proofs can, well, sometimes it could be lengthy, but it depends on how you want to go about it. So, to make it simple, right, we're just going to take the simplest form of each one. So, for instance, now, Cn, Cn's own is looking like this, n squared plus n. Okay, n
Okay,
squared
sir.
plus n over what? 2. Alright, and they're talking about their sum. So let's put a big plot between them. Again, that plot looks funny. Okay, alright. So let's put that big plot there. And then we'll now do Cn plus 1. Look at what you. Okay, so I'm going to use this one on the right. Okay, so that in fairness, it looks like the one on the left somehow. N squared plus 3n, okay, plus 2 over what? 2. Okay, so the same thing with this. It's still the same idea. In this case now, the LCM is what? 2.
2.
So 2 in itself, 1. 1 times the numerator is n squared plus n. Okay, put your plus sign there. 2 in itself again, 2 in 2 is 1. 1 times the whole numerator is what? N squared plus 3n plus 2. Okay, so the next thing we're going to do now is to collect like terms. So if we collect like terms, what do you think will happen here? I can see n
Mm,
squared, n squared. That will give me 2n squared, isn't it?
2 and is
Then I can see, yes, go ahead. N plus 3n, right?
Shall be 3
this one,
no, n
and
squared.
this one.
Or 3n squared.
Okay. So is it three? No, look very well. Oh. It's not 3n squared. Look very well. This one is n squared.
Oh,
This
3n
one is
cubed.
n squared. Right in front. Eh? Is it 3n? No, not 3n cubed. Just look very well. Oh. N plus 3n. Do you understand?
Okay, 4n squared.
So that's
Okay,
4n.
n plus 3n. Oh yeah, that's 4n.
Just 4. Yes, yes, that's 4n. So we now have plus 2. 2 is alone. It doesn't have anyone that is with it. Okay. So our job now is to prove that this thing is the square of a number, a natural number. Okay. Remember, n is a natural number. So if we can find something that looks identical that is multiplying itself, that's just the trick to this thing. There's no big deal. It's not anything special. In fact, if you ask me, it's okay that we did it like this. So the next thing we're supposed to do now is to look for how to make that guy on the top along with the one underneath. Well, to look for a way to reach that. Because to make it look like itself. Now, what do you think we can do to this? Me, I can take out that two that is underneath. There's a way I'm even looking at taking it out. You can see that clearly. This thing you can write it as 2n squared over 2 plus 4n over 2 plus 2 over 2 to give me, of course, you already know what I want to do. 2 will take itself out. Again, 2 will take itself out and 4 2 times. And finally, 2 will completely take itself out here. And you're left with n squared plus 2. I'm sure if you are really looking at this thing, the answer should already be plain in your mind by now. Plus 1.
1.
Now, does this not look familiar? Does this not look like the square of something? You know, what are two numbers and when we multiply them, they will give us 1? Well, remember, that's the question, that's that simple method. When we multiply them, they will give us plus 1. When we add them, when we add them, they will give us 2. So this one is the answer to addition. This one is the answer to multiplication. Simple, isn't it? Can you see it?
Yes, I can.
Do you even know that method? Let me not as you know that method. Do you know the method I just said now? The method for
What method?
solving quadratic equations where you want to factorize, where you ask yourself, what are two numbers? When you multiply them, you get the number at the end, which is in this case plus 1. If you add them, you will get the number in the middle, which in this case is plus 2. It's a method for solving quadratic equations. When you cannot use this method, then usually people now go to use almighty formula, just like we did back there. Okay. So I was asking, do you know that method or not?
I don't know the method.
Oh, so let me ask you, if you don't want to use almighty formula, how do you solve your quadratic equations? How else do you solve it?
Is he using the T formula?
Because
Mm.
right now we just need to make this thing look okay, okay. So what's let me see. Let me maybe it's the name, whatever we're calling it. What do you call your T formula? Is it almighty formula or
Uh, we call it general term or general form.
now general term? Okay, no, 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 no. This one is not.
Is
I
it
don't
the
know
AN
which.
squared
Yes, like that one,
plus
like that one.
BN?
So we want to solve it. Yes, but we don't want to do the we don't want to use that almighty formula. I don't know, Sha, but me, I feel that we can do something really simple. Okay, let me just show you the method. Let me teach you the method if you don't know it. So um ah so let me see if I can back up with this. I'll use a box because this is not part of our working. Yeah, I think this box is in there. Okay, so this method, it might even be something you already know, right? It says that if you have, let me just do it as simple as, I'll just make it as simple as I can. A plus B all squared is the same thing as A plus B, right? Times A plus B again. Alright, so now, um, just to make it simple, we'll take this A and multiply A, and next we'll take this A again and multiply B. Okay? Then after that, we'll now take B and multiply A, and we'll take B and multiply B. Okay? So if you understand this basic this thing I just did now, I'll take this A and multiply A, and I'll have what? A squared. Take this A again and multiply B, it will give me plus AB. Okay. Take B and multiply A, I'll have plus AB again.
AB.
BA, we know that BA and AB are the same thing, so there's nothing to worry
Yeah.
about. And then finally,
And
take B and multiply B, and
B
you
squared.
have what? B squared. Now, I want you to see what will come out at the end of all this. You have that A squared plus 2AB plus what? Plus B squared. So, so typically, right? Sorry, I went and wrote 2B. Okay, let me erase that middle guy. It's only the middle guy that is wrong now. Okay, so now the whole idea is that um um if you wanted to go from here, right, back to here, you would, well, technically, you would first take this term. If you look at it very well, A squared and what? B squared, and and then if you look at it very well, the the A squared and B squared, is already giving themselves away, as if you know the two numbers that when you multiply them, they will give you themselves, right? And then when you add them, they will give you the number in the middle. So that's ABAB. I don't know if what I just explained now made it simple or I don't want to introduce another complexity. Okay. Mm, okay. But okay, so let's maybe I don't want to make it more I don't know. Should I leave it? Okay. Let me just leave it there. Okay. So the whole idea is this, we just want to be able to break this guy down into two brackets that we can see. All right, and maybe it's my choice of this thing. Maybe I should have taken this. I think that's what I should have done. So that since you understood the one on the right hand side, I should use that one instead. Okay, so you know what then?
Okay.
Just try and taking this formula. Okay, try and understand this method of solving quadratic equations. I promise you, it will be something that you would really love because if let's just pretend though it's not equal to zero. I'm just saying let's just pretend if this was the scenario and they told you to solve this quadratic equation, I promise you, going to go and use almighty formula to solve it is like using a hammer to kill an ant. Okay, do you
Okay.
understand what I'm trying to say? It's like using a very big, complex something to do something so simple. So but then of course the principle is that what make this thing to be into two brackets and then tell us that one bracket equals zero, the other bracket or the other bracket equals zero, and then solve it. That's just the simple principle for solving quadratic equation. But in this case now, we don't have anything like equals to zero. So our job is just to do what? Split it into two brackets. And the best way to split it into two brackets, whenever, especially when the coefficient of the squared is one, okay? When the coefficient is one, so the simplest way is to just ask yourself, what are two numbers, okay? Two numbers such that when you multiply them, they will give you this number. This one is answering the question for multiplication. And then when you add them, they will give you this number. This number, the of course, you have to also take it with its sign. It will give you this number, the coefficient of the one that is in the middle. That's the one that is just n, not the n squared though, n. Okay, so this one answers the question for addition, ADD, and then this one answers the question for what? Multiplication. Let me just put it as MULT. Okay. Once you can find two numbers that will meet that criteria, you have you have already found the two numbers for your bracket. So now, I'm sure you already have those numbers in your mind. The only two numbers when you multiply them that will give you plus one is one times itself, isn't it? And then
Yes,
when
sir.
you add it, with two, it's also one times itself. So that pair of numbers thoroughly satisfies our equation. Guess what? All need to do is to take one of the n squared. Just take one of them, and then just do what? Put in one of the brackets n, open another bracket, put the second n, and then what next? You put the two numbers that you found that meet that criteria for multiplication and what? Addition. And the two numbers are identical. And this is what we wanted to do. We wanted to see if we can express all our, because it's a proof. Okay. So since we can express this thing as something identical times something identical, then obviously it is in the format of k squared. You get where k squared, where k is an element of what? Natural numbers. Now let me ask you something. Uh, n is it not n is a natural number, isn't it? Small n, this n, which is a position, is a natural number, isn't it? If you add one to a natural number and multiply it by itself, will it not still give you a natural number?
Yes, sir.
So that means our proof is satisfied. So based on that, our proof is is, is good. Okay. Now you don't, please, this is not part of the proof, so that you don't, then maybe I just, that's why I put it in a box. So this one is just for your own consumption. But this bit starts from here. Okay, all the way down. Okay. So you want to do a screenshot?
Yeah, I'm taking sure.
Okay. All right.
Yeah, yeah.
Okay, good. All right. So let me see. We are still pushing this triangular number thing. It says two consecutive triangular numbers sum to 12,500 and what? 44. It says find the smaller of these two numbers. Okay, so this one is the sum. Um, so this one we'll we'll use okay, the smaller of these two numbers. Let me see. 12,544. All right. So based on what we just calculated now, I think we can still push it further. This is alright. So um our sum of two triangular numbers, we can take it back to n squared plus 2n. You know,
Yes, sir. Hello, sir.
yes, you can see my screen, right?
I can see it. Okay, I can. It's loading. I can see it now.
mm, mm. Okay, okay. Okay, so it's a thing that would need us to do um almighty formula again. So you can goodness, can you hear me now?
Yes, sir.
Your mic is mute. Okay,
Yes, sir.
okay. All right. So what did you get when you multiply 4 by that number? So what did you get?
Hello, sir. I can't hear you very well.
What, uh, what, one, so goodness, confirm if this is correct. When you multiply 4 by that number, is that what you got?
Uh, I can't see anything on my screen. Ẹ ti fún mi ní kinní yẹn, ó ti no, because I just hello, sir. Yes.